This is question 11 from the GATE 2018 EE paper, where we are given a real valued function f of x, which has definitions x square for x greater than equal to 0 and minus x square for x less than 0. We are asked to find out which one of the following statements is true about f of x. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic.
Yeah, so in this question, we are given that f of x is defined as x square for x greater than equal to 0 and minus x square for x strictly less than 0. And are asked to find out which of the following statements are true. Right? So let's look at what the plot of f is. So this is the plot for f, right? It's x square for x greater than 0 and minus x square for x less than 0. This is its derivative. It will be x for x greater than 0 and minus 2x for x greater than 0 and minus 2x for x less than 0. And this is the double derivative, that is f double dash. So this is f dash, this is f. So, and of course f double dash will be 2 and minus 2. So it is quite evident that the correct answer is that it is continuous. It is differentiable, but its first derivative is not differentiable at x equal to 0. That is, this is f of x. It is differentiable because it has a derivative, but of course f dash of x has a kink, that is a point which is like that at x equal to 0, which is to say that it is not differentiable over there. This is, visually we can see it. The answer is D. But how do we derive this mathematically now, right? So the idea is that we will have to look at each option one by one. Option A alleges that it is discontinuous at x equal to 0. The continuity formula is that limit x tends to a is equal f of x is equal to f of a, right? You can clearly see that x tends to 0 f of x, 0 minus and 0 plus are both 0, right? So if you take x square over here and minus x square over here, you will find that it's 0 for both, right? And that is equal to the 0 value, so it's not option A. Then option B is saying that the derivative does not exist at x equal to 0, but it's continuous, right? So we've already established continuity. Let's look at the derivative. Right, again the derivative expression df by dx at x equal to c is equal to limit x tends to c f of x minus f of c by x minus c. Right? So the idea is that for x tends to 0 minus f of so luckily for us f of 0 is 0, so it's just looking at the f of x by x relationship. So it's minus x square by x, which is limit x tends to 0 minus x, so that's 0, and similarly it will be plus x over here for x tends to 0 plus, and that will be 0. The LHL equal to RHL, and so you can say that the df by dx at x equal to 0 exists. So it's not option B either. Right? Option C. Option C says that f of x is differentiable, but the first derivative is not continuous at x equal to 0. So yes, we have established differentiability at x equal to 0. So let's look at the function g of x is equal to df by dx. This will have the following definition, right? Just by taking the derivative of the original function for both these regions, and you will see that limit x tends to 0 minus g of x is equal to limit x tends to 0 plus g of x. It's evident from the definition itself. You have to just substitute minus 2x here and 2x here and take the limit to 0. You'll find that this is equal to the 0 value. So the function is continuous, and so it's not option C. So therefore, by elimination itself, it has to be option D, right? But of course you can work it out, and you'll see that the left hand limit is not equal to the right hand limit, and so therefore d square f by dx square at x equal to 0, it does not exist. This is a limit and it does not exist, right? So the answer is option D.